Hello, I'm Melanie Schranz from Lakeside Labs, and I will present the Swarm-based Workload Manager from the MYRTUS project Work Package 5 and 6. In Swarm systems, the agents follow local rules without centralized controllers, resulting in scalable, robust, and adaptive solutions. These characteristics make agent-based swarm intelligence methods particularly well suited for optimizing resource allocation and task distribution in the heterogeneous and dynamic edge-fog cloud environments. Local rules are built with nature-inspired engineered swarm algorithms, like we will demonstrate with the ant colony optimization algorithm, or by using evolutionary algorithms with the tool Frevo. Both approaches use the simulation framework Cosmos, a simulation framework that was specifically built for the agent-based simulation of the edge fog cloud continuum in this project. In the considered edge fog cloud continuum, the agent-based model of our approach consists of two types of agents. Resource agents that can be edge, fog, or cloud agents with specific CPU and memory resources available, organized in a multi-layer hierarchical network topology, and the demand agents that can be represented, for example, by pods as in Kubernetes, containerized data that needs to be processed by the network and comes with demands on CPU and memory, plus maximum latency indications. So we already built a swarm library of two swarm algorithms, the ant colony optimization algorithm that we will also use exemplary for the demos in this video, the hormone algorithm, and one algorithm that is created as multi-layer perceptron using evolutionary computation with the tool Frevo. The random walk and the greedy algorithm are included as baselines. There is already a set of papers to show the progress in this field. With the ACO algorithm, we are able to find the right path for the data to be processed in the edge-fog cloud continuum, where these demand agents, or the ants, release pheromones and perform pheromone updates on the corresponding resource agent. They are currently examined. So you can find all details for the algorithmic principles in the publication mentioned below. We will demonstrate now the functionality of the ACO for the mobility use case, so cameras that are observing a crossing in the MYRTUS project, consisting of 5 cameras as edge nodes, 1 fog node, and 3 cloud nodes. In this demo, we want to showcase the functionality of the simulation framework Cosmos when evaluating agent-based models for our edge for cloud continuum. We use 1,000 pods and replicate the mobility use case network with 5 edge, 1 fog, and 3 cloud nodes. What is to say here is that the swarm-based simulation framework is not made for networks with a low number of agents, where we have a very structured connection among the nodes of the hierarchies, where, for example, every edge is connected with a fog node. We cannot observe an emergent behavior of the system. So we see a lot of utilization results now for the different kind of nodes, edge, fog, and cloud. And finally, for the main metric, the fog dependency is around 50% and the cloud more than 20%. Therefore, we also want to analyze the swarm-based workload manager with a bigger visionary use case also related to mobility. A future smart city use case where we do not consider only one crossing to be observed, but multiple of them. So what we do is to scale the network by 20, resulting in 100 edge, 20 fog, and 60 cloud nodes with 20,000 pods that needs to be scheduled. This will show us a direct comparison with the real mobility use case. So these graphs show now an overview of the utilizations of all the nodes that we are modeling. But the output that is the most important one comes with the fog and the cloud dependency, where we can see in this graph that we can reduce the fog dependency from 50 to 35 and the cloud dependency even more to smaller than 1%. This shows us the huge potential in a highly connected network with a reasonable number of interacting agents using the swarm principle. In summary, it is to say that in a decentralized system that supports self-organizational concepts, the swarm-based workload manager is to be used. for example, in ad hoc, mobile, complex, and dynamic networks, where additionally scalability across hundreds of agents can reach a performing system. Hence, energy efficiency and fault tolerance are top priorities. The swarm based workload manager is not to be used if predictable behavior is required for critical applications due to the emergent behavior of the self organized system approach, and as you've seen, for a reduced amount of agents. Next steps include huge evaluations on the emergent behavior with various network configuration, and then the integration to the mobility use case with mixed physical and virtual agents to reach this critical point where the swarm performance starts. Thank you very much.